Hello everyone and welcome back to SGTV. So today I am joined by Tim Benstead, who works with us here at Scolmore Group. And Tim, what else is it that you do?
I do odds and ends. So part of my role is I also am chairman of JPEL B, which is the subcommittee dealing with thermal effects. I'm involved in other BSI committees, light and lighting application and fire detection, fire alarm systems and emergency lighting and other bits and pieces that sit around that. So varied, but typically around standards.
Yeah, so safe to say that you know your stuff when it comes to regs and all things wiring.
All things wiring are pretty good. Outside of that, Muppet, but in the wiring,
I didn't want to say anything, but that's why we brought you in today. Is we've actually put together a list of questions based on USB sockets. They're questions that we get asked a lot from our customers, things we're seeing online. So we thought we'd compile them and try and pick your brains and see if you can answer them for us.
Yeah, happy to help.
The first one is, why would you do an insulation resistance test when USB sockets are already connected to a circuit?
We're required to do an insulation resistance test. That's the simple answer, is insofar as BS 7671 is concerned in Chapter 64, during erection and on completion, we are required to carry out an insulation resistance test. And it doesn't much matter what the piece of electronic equipment is. If that's been second fixed and it's connected to the circuit, then that whole connected installation needs testing. What you have to do, of course, is be careful that you check that any connected electronic equipment can withstand the nature of an insulation resistance test or not. And you may have to then put some bits in place to avoid damaging any bits and pieces, like potentially USB sockets. Okay.
The next question we've got, is it common for device cables to not be rated to what they're spec'd as?
I think probably what sits behind the nature of this question is, shall we say an answer, is you get what you pay for. If you're buying cheap and cheerful off a market stall, not all market stalls necessarily, but let's assume that it's nice and cheap. Nice and cheap means generally nice and chatty as well. And so inherently, I would always recommend that you go to reputable sellers and make sure you get that, because then that isn't an issue.
Yeah, and this isn't really anything to do with the installer, is this? This is more aftercare, but it's something that it might be worth advising to your customer, to the homeowner. Once you've installed this, you know, whether you've got any kind of guarantee on your work or anything like that, but it is really down to the equipment they're plugging in. They need to be careful with.
Yeah, absolutely, absolutely true.
Next question we've got. Do you need separate test equipment for testing the output of the USB sockets?
So what you mean by that, of course, is these points.
Yeah, so here. I'm sure a lot of our electricians watching this, they're familiar with testing a normal socket. But USB sockets, they've been around for a while, but not necessarily everyone will be all that clued up on installing and testing them.
Yeah. There is currently no requirement for testing of specifically USB outlets of any type. So the normal tests are carried out for insulation resistance. You don't plug anything in, you don't have any loads connected, and when you buy a product with the USB ports on them, you assume that that's been type tested to the standard relevant for that, and it's been manufactured appropriately. Then they don't need testing by the installer.
Okay. The next question we have, what's the purpose of testing at 500 volts?
We test at 500 volts because we need to ensure that the potential damage we've done as installers when we're drawing cables in, whether we've got the bending radius correct, whether we've damaged anything by the nailing of cables, by any of that sort of stuff, we need to pressure test and stress test, if you like, the installation, and 500 volts is what the minimum voltage is for stress testing an installation. Once you connect up your accessories, your socket outlet switches and the rest of it, then you can reduce the voltage to 250. But obviously it depends on the manufacturer. For example, I think, am I right in saying that we can test this at 500 volts?
Yeah.
So insofar as Scolmore Click is concerned, then you can carry on quite happily at 500 volts and you're not going to damage the electronic elements of that. But you would have to be careful.
Yeah, so if one of our customers was going with a different manufacturer, just be careful, just make sure you're checking
Yeah.
that they are
Yeah.
rated to,
Yeah.
to 500
Yeah.
volts
Yeah.
in test.
And of course, when you're carrying out the test, what you would then think about is the nature of how you carry out that test. You would still potentially connect line and neutral to earth, or line and neutral together, and then test to earth, because then you don't get the problem associated with testing between line and neutral and the connected equipment, which would tend to give you a slightly dodgy reading on your insulation tester anyway.
Right, okay. So that sort of goes into my next question, which is when is it acceptable to test at 250?
When you've got equipment that you're trying to protect, is the ideal. Or when you're testing at self, PELV levels of voltage, you can drop the voltage then. But when you're at 230, it's 500. If you drop down to 50 volts, then you can test at 250.
Okay. The next question, actually, yeah, this was an interesting one, is can you turn the USB sockets off from the switch? So obviously, if you've got a device plugged into this, you can switch it on or off.
Yeah.
Is that the same for the USB inputs?
I don't think so. I think you'll find that they're permanently connected. I think you wander in, you plug it in at your hotel or whatever, and it's going to be powered on. You're not, because of course the switch is controlling the 13 amp device. You're not too worried about a 5 volt maximum voltage. It's not a concern to us.
Okay.
So from a safety point of view, that is anyway.
And that's what you do. It is from a safety point of view. That's why you're here. And the next question is, what can you do to ensure testing equipment doesn't get damaged? So we have heard of people, when they're testing out USB sockets and other sockets, they're often damaging their equipment. So what's going wrong there?
If they're damaging their equipment doing an insulation resistance test, it's likely they're probably not isolating beforehand and they're connecting up to a live circuit.
Right.
An insulation resistance test is a dead test, and because it applies DC to the circuit. Now, manufacturer test equipment may have a means of providing warning, but particularly if you've got older instruments, then there could be a problem. If you're doing an insulation resistance test, safely isolate first, carry out the test then.
And they should be doing that, whatever they're doing anyway, shouldn't they? Exactly.
This is not a USB question, if you like. It's a standard testing process question.
Okay. How have USB sockets evolved compared to what they were?
Yeah. It's an interesting one, isn't it? It's a relatively new development. It's really only going back to initial patents over the last 15, 20 years maximum. And as with all of these processes, it's manufacturers that drive it, typically, and it's legislators and regulators sort of play catch up with it. So, of course, once we had the initial, or the one we got used to, which was the USB-A, and this has been our tried and trusted friend for a long time. And it's got a certain data transfer rate that's fantastic, but it's finite. And then, of course, with developments, you want to increase the data transfer rate, and manufacturers moved towards the USB-C. One manufacturer, specifically a major manufacturer, they had, if I remember rightly, the Lightning connection. And there was a lot of work done on that. However, the EU sort of did suggest that this was inappropriate, and they would really rather you liked a common way of approaching this. So they liked the USB-A, they liked the USB-C, and they said to that particular manufacturer, either you do something specifically for the EU, or you don't sell in the EU, or you might want to decide to go USB-C.
That's some motivation.
And it did motivate them to move that way.
Okay. And that's why we're seeing a lot of phones, tablets, laptops, all of that kind of thing. Yeah. Well, not laptops, but they're going more towards USB-C.
Yeah, and the data transfer rates are much better on a USB-C.
So how many USB sockets can you have on a circuit, and does it matter if it's ring or radial?
I suppose this is one of those, how long's a piece of string? So in terms of what's permitted in terms of a ring final circuit, we already know we are permitted any number of sockets to sit on that ring. What we're not allowed to do is to then load it beyond the 32 amps that's available for its supply. Similarly with a radial circuit, we can have a 20 amp radial circuit, we can have a 32 amp radial circuit. You get the size of conductors associated with it. And the rating of the protected device puts a cap on what you can do. So on a 20 amp device, That's what you've got. On a 32 amp, that's what you've got. You're not allowed to put an overload on purpose to overload it. So coming back to how many USB ports can you have? Any number. The cap still sits there.
Yeah.
So once you hit a certain value of current, then you can't. But we know, even if you had 50 socket outlets on a ring final circuit, we don't have 50 appliances to plug in all drawing current.
Have you met my kids?
There is there is that. And it can be, for example, a home office where you've got a shed load of outlets because you've got printer, monitors, you've got, you can have any number. Of course, what you then do as a designer is you say, well, actually, I'm going to do a separate circuit just for this, and then I'm going to do a separate circuit for the rest of the bits, and then one for your kids, just to allow them to have any number they like. And you just grow the size of your consumer unit and do your design calculations accordingly. But insofar as the numbers that are permitted, there is no cap. In the same way there's no cap for socket outlets.
Yeah, so they're only going to be drawing what they're allowed to draw, basically.
For example, 5 volts DC, 4 amp shared. So you've got a total of 4 amps. That's it. And that's finite there. This one, you can do 5 volts, 3 amps, and 5 volts, 4.2. So it's finite. It's cap limit. You go beyond that number of 4 amps. Then you start bumping up to your 32 or your 20 or your whatever. There you go.
And if you overload, you're just going to trip the socket anyway, trip the mains.
That's it. You're going to take your circuit breaker out.
Okay.
Yeah.
So that brings us to an end of this episode, really. We wanted to keep it pretty short and sweet, informal, and we hope you found that useful. If you have any more questions like this that you'd like myself or Tim or Jake or any of us here at Scolmore Group to answer, please do get in contact. Leave a comment in the descriptions, and we'd be happy to put an episode together and try and shine a light on some of these questions.
Yeah, we muddle our way through.
Yeah, we'll figure it out. As always, please remember to like, subscribe, hit the notification button below, and we'll see you on the next video.